Alright, so good night to everyone. Welcome to Moyo Math. Tomorrow is your Addmath examination, and tonight I'm not going to stay very long in live tonight, but we're going to look at key topics and questions that we often see in the exam. I want to ensure that we are prepared for. So when you enter the exam tomorrow, and if you do see a similar question, you will know how to proceed to answer. Alright, and of course work towards getting that distinction in your Addmath. Okay, so tonight we're going to look at, we'll start with section 1, looking at remainder factor theorem, then we'll get into question 2, dealing with all the quadratics. We will look at EPGPs, we'll get to section 2, looking at equation of a circle, looking at sectors, vectors, trigs. We have differentiation, integration, and of course you have combined with that a bit of kinematics. You have stats probability, alright, which will be section 4. So, like I said, I'm not going to stay very long, but let's see how much we can get done within the time, alright? Again, don't forget to like, share, and subscribe to Moyo Math, okay? So let's get started. Alright, hi Nikolai, hi. So let's get started. Alright, so we're going to begin with remainder factor theorem. And again, this is a common question, certainly you're going to see in the exam tomorrow. So when you open that paper, I'm sure one of the first, or part of the first question will be a remainder factor theorem question. Now, you know remainder factor theorem will normally ask you to find the value of some unknown quantity. So in this case, if it states, given that 3x plus 2 is a factor of that cubic polynomial, 3x cubed plus bx squared minus 3x minus 2, find the value of b. So if they mention 3x plus 2 is a factor of the cubic polynomial, if it is a factor, it means that it can divide exactly into that cubic polynomial and the remainder is automatically 0. So this is what we need to remember. So we have, so to answer this question, part 1, we have this cubic polynomial. So let's call it f of x, given, even though f of x is not attached, you can call it f of x. Given f of x is equal to 3x cubed plus bx squared minus 3x minus 2. Given f of x is equal to that, and we have 3x plus 2, which is a factor of that cubic polynomial f of x, find b. So we know if 3x plus 2 is a factor, we automatically know that the remainder is 0. So we're going to say let 3x plus 2 equal to 0. 3x will be equal to negative 2. We divide both sides by 3. X is negative 2/3. Alright? So I know that when I substitute negative 2/3 into that cubic polynomial, I'm supposed to get 0. So therefore, f of negative 2/3 will be equal to 0. So what we have here is an equation created because we are solving for the unknown quantity b. So you must create an equation. This is our equation created here. And therefore, to solve that equation to find b, I'm going to substitute negative 2/3 into my cubic polynomial for x. So this will be 3 open brackets, negative 2/3 in brackets cube, plus b, negative 2/3 in brackets squared, minus 3, negative 2/3 in brackets, subtract 2 is equal to 0. So we have our equation created there. Alright? So this becomes 3, negative 2/3 cube will be negative 2/3 by negative 2/3 by negative 2/3, which will be negative 8 all over 27. We're going to get negative 8 all over 27 plus b into negative 2/3 squared will be positive 4 over 9 And negative 3 by negative 2 over 3 will give us positive 2 minus 2 is equal to 0. Of course, we can simplify that further. The aim is to find b, so we're solving for b. So my 2's will cancel at 0. 3 by negative 8 all over 27 will give us negative 8 all over 9 plus b by 4 over 9 is 4 over 9b is equal to 0. So now let me solve for b. So I'm going to take my negative 8 over 9, I'm going to add 8 over 9 to both sides, or I'll take negative 8 over 9 and bring it over to become positive 8 over 9. So this will be 4 over 9b is equal to positive 8 over 9, and therefore we can solve for b by dividing both sides by 4 over 9. So I'm going to divide what is on the left by 4 over 9, and I'm going to divide what is on the right by 4 over 9. So my two 4 over 9s on the left will cancel out. So they divide into each other to give 1, you get b. And therefore b is equal to 8 over 9 divided by 4 over 9. So that's 8 over 9 divided by 4 over 9. Can we write it like that? So b is equal to 8 over 9 multiplied by invert 9 over 4. So my two 9's divide into each other to give 1. 4 can go into A2. So the value of b is 2. So look out for a question like this. It's highly possible you can see a question like this where you have to solve an unknown quantity b. Alright? Sometimes you'll see cases where you have to find some unknown quantity. I shouldn't say just b, but it can be any unknown, right? Depending on the unknown in your cubic polynomial or polynomial. So they also ask us to factorize completely. So we look at this part of it. So with remainder factor term, it's important to know how to factorize a cubic polynomial. Sometimes they'll bring this in the exam, they'll ask you to factorize a cubic polynomial. So let's make sure we can factorize a cubic polynomial. So how do we factorize a cubic polynomial? So to factorize a cubic polynomial, so we have 3x cubed plus bx squared minus 3x minus, so now we use the word hence factorize. So using what you got before in part 1 of the question to help you with this part of the question. So really part 2, this cubic polynomial can be rewritten as 3x cubed plus, replacing b with 2x squared minus 3x minus 2. So that's the cubic polynomial we want to factorize. And factorizing a cubic polynomial, what you want to do is to represent it as a product of factors. Okay, that's factorization generally. So to represent this as a product of factors, we want to see, when you ask to factorize, you want to see our end result looking something like this. You know, three factors or 3 binomials, we call them binomials. Now already we know one of these binomials will be, as mentioned before, one of the binomials, it is 3x plus 2. Because it told us 3x plus 2 is a factor of that cubic polynomial. So one of the binomials will be 3x plus 2. So we already know one factor. So what we want to do is to find the remaining factors, the remaining 2 factors. So to help us to find the remaining 2 factors, what we're going to do is carry out our process of a long division. So let me erase here. So we're going to carry this process of long division to find the other 2 factors. So I'm going to divide 3x plus 2, which is my divisor, right? Because it told us 3x plus 2 is a factor of that cubic polynomial. So already you know one factor, 3x plus 2 is my divisor, and I'm going to divide my divisor into my cubic polynomial which is your dividend. Alright? So we're going to divide 3x plus 2 into that cubic polynomial. So how do we divide? Using long division. We want to first ensure that we have all powers of x in descending powers of x. That's important to ensure first. So you see I have x to the power 3, x to the power 2, x to the power 1, and x to the power 0 is understood here. Right? So x to the power 0 is 1, and hence this will be remain as negative 2. Alright, so this here is the same as negative 2x to the power of 0. But x to the power of 0 is 1, so therefore you have negative 2. Alright? So it's already in descending powers of x, which is good. And once it's in descending powers of x, let us now try to carry out our elimination process. So I want to get rid of my terms involving x cubed first. So I want to remove 3x cubed. And then I want to eliminate my terms involving x squared and x, and of course my constant. So I want to carry out this process of elimination so I can obtain what you call a quotient. So what is on top here will be a quotient, and of course we expect to get our remainder as 0, because this is a factor. So when I divide it into my cubic polynomial, my remainder should be 0. Alright, and I'm also working towards obtaining a quotient. Alright? So, let's carry out our process of elimination. I want to get rid of 3x cubed, so I must make sure I have 3x cubed under 3x cubed. So, what am I going to do to ensure that I get 3x cubed under 3x cubed? So first you tell yourself, what must I multiply by 3x to give me 3x cubed? Alright? So what must I multiply by 3x to give me 3x cubed? And if you're not sure, you're going to divide 3x into 3x cubed. When you divide 3x into 3x cubed divided by 3x, you're going to get x squared. So you're going to place x squared in your quotient. And what you're going to do next is to multiply x squared in your quotient by 3x. So when I multiply x squared by 3x, I'm going to get 3x cubed. So you see how you now have 3x cubed under 3x cubed. So you can easily subtract and eliminate it. But I'm not only multiplying x squared by 3x, I also have to multiply x squared by plus 2. Because my divisor comprises of two terms, 3x and plus 2. So x squared by 3x will give me 3x cubed, and x squared by plus 2 will give me plus 2x squared. Alright? What I'm going to do now is subtract. So when I subtract, what's going to happen? I like to follow through with my subtraction sign. When I subtract, what's going to happen? 3x cubed subtract 3x cubed is 0. So that's eliminated. Let me now subtract my terms involving x squared. So 2x squared subtract 2x squared is also 0. Alright? And normally with long division, after you subtract to get your remainder, you often bring down. Alright, so I subtract 3x cubed from 3x cubed, 2x squared from 2x squared. I'll get 0 in that case. And what I'm going to do is to bring down negative 3x. Right? So now, let me divide 3x plus 2 into negative 3x. Now what's going to happen here? 3x plus 2 into negative 3x, I'm going to say cannot. Alright? So I'm going to divide 3x plus 2 into negative 3x. I'm going to say cannot, so I'm going to place 0 here. And what I'm going to do next is bring down my negative 2. So 3x plus 2 cannot divide into negative 3x as is. Alright? We want to ensure we have a constant as well attached. And that constant will come from bringing down negative 2. Now I can divide 3x plus 2 into negative 3x subtract 2. Yeah? I can divide this into this now. Alright? So how? Now I want to eliminate negative 3x. How am I going to eliminate negative 3x? So to eliminate negative 3x, I I want to ensure I get negative 3x under negative 3x. I want that to happen. So how will I get negative 3x under negative 3x? So you tell yourself, I'm going to take my 3x here and I'm going to divide 3x into negative 3x, which will give me what? Negative 1. So I'm going to put negative 1 in my quotient. And when I take negative 1 in my quotient and I multiply it by 3x, I'm going to get negative 3x. So you see now I have negative 3x under negative 3x. So when I subtract, these two will be eliminated. So that's how you eliminate it. Tell yourself, alright, so you take the first term in the divisor and you tell yourself, what must I multiply by 3x to give me negative 3x? And if you're not sure, you take this 3x and divide it into negative 3x. So 3x divided into negative 3x will give me what? These two cancel. Negative 3 divided by 3 is negative 1. So you make sure you put negative 1 in your quotient. And then you're going to multiply negative 1 by 3x to give you negative 3x. And negative 1 by plus 2, to give you negative 2. And what's going to happen here now? Let me subtract. So I have negative 3x under negative 3x, and I have also negative 2 under negative 2. And look what's going to happen here. When I subtract those two, negative 3x subtract negative 3x is 0. And negative 2 subtract negative 2, that's also 0. So what I have here, when I divide 3x plus 2 into my cubic polynomial, I have obtained two things. My quotient and also my remainder, which must be 0. Alright? Because 3x plus 2 is a factor of that cubic polynomial. So my remainder must be 0. Alright? So once I have all this important information, now let me represent this cubic polynomial as a product of factors, hence factorizing it. So to represent it as a product of factors, I'm going to write 3x cubed plus 2x squared minus 3x minus 2. I'm going to rewrite this as my divisor multiplied by my quotient plus my remainder. This is how you express your dividend. Your dividend is always represented as your divisor times your quotient plus your remainder, which is 0. Alright? This is what your cubic polynomial is represented as in terms of factors. Alright? So I factorize it here, no? 3x cubed plus 2x squared minus 3x minus 1 as a product of factors is what I have here. I factorize it. But note, this can be factorized further to get it in this form, 1, 2, 3. So you can have 3 sets of factors, if possible. Alright? So in this case, it is possible because x squared minus 1 can be further factorized. X squared minus 1 can be factorized using the method of the difference of two perfect squares. So you can write this as 3x plus 2. And we know to factorize this x squared minus 1. This is x by x, 1 by 1. Subtraction sign represents the difference of two perfect squares. I can put my two sets of brackets, take the factors of x squared, let them lead. So you place them first, then the factors of 1, they will be written after. And you always separate with a positive sign in one binomial, a negative in the other, or negative positive, it doesn't matter the order. So this becomes 3x plus 2, x plus 1, x minus 1. And this is factorizing the cubic polynomial. So we got the value of b, and then they ask us to factorize the cubic polynomial. So we can use this method of a log division to help us to factorize the cubic polynomial, where you're going to get a quotient and you must get a remainder of 0. Using your method of log division will allow this to happen. Right? Once this is a factor of the polynomial, the remainder will automatically be 0. And of course you will obtain your quotient. So to factorize it, this cubic polynomial represented as a product of factors will stem from multiplying your divisor by your quotient. Divisor by quotient. Alright, so this is factorizing this expression. This represented as a product of factors. But always check to see if the expressions can be factorized even further. X squared minus 1 can be factorized even further. So we use the difference of two perfect squares to do so. And therefore we have this as our final answer. Alright? So this is factorized. So something you need to look out for when they ask you to factorize a cubic polynomial and what you do. Alright? Also, let's look at a case where sometimes, what do we do sometimes? They will ask you to find for two unknown quantities. So with a remainder factor theorem question, you can be asked to find one unknown, or sometimes with a remainder factor theorem, you can be asked to find for two unknown quantities. In this case, they want us to find C and D, two unknown quantities, which means you have to create a pair of equations and solve them simultaneously. So that's something you have to look out for. You can see that in your exam tomorrow. Alright? So when the polynomial expression 2x cubed minus 3x squared minus cx plus d is divided by x plus 1 and x minus 2, the same remainder of 64 is obtained. Determine the value of c and d. So we have to solve for two unknown quantities, which will imply we have to create two equations. Just remember that, and we have to solve them simultaneously. So that should automatically kick in. Alright? So, how are we going to create our pair of equations? I'm going to state given, so there is no image of x, that is the f of x, g of x, and so on attached to it. So I'm going to attach one to it. So given f of x is equal to 2x cubed minus 3x squared minus cx plus d. So I have that cubic polynomial. It is divided by x plus 1 and x minus 2, and the same remainder of 64 is obtained. So the same remainder. So when I divide x plus 1 my divisor into that cubic polynomial, I'm supposed to get a remainder of 64. Good? So how am I going to establish an equation? By dividing my divisor x1 plus 1 into my cubic polynomial to give me a remainder of 64. How am I going to create an equation based on that? Look how simple. I'm going to let the divisor x plus 1 equal to 0, and therefore x is equal to what? Negative 1. So when I substitute negative 1 into this cubic polynomial, which I'll write as f of negative 1, when I substitute negative 1 into that cubic polynomial, I'm supposed to get the remainder of 64. Alright? So this here is your first equation. So to ensure it's in the form of a visible equation to you, you will substitute negative 1 into the cubic polynomial. So this will be 2, negative 1 in brackets cube minus 3, negative 1 in brackets squared minus c, negative 1 in brackets plus d is equal to 64. Alright? And therefore, when I simplify this, I'm going to get what? Negative 1 cube, it's negative 1 by negative 1 by negative 1, that's negative 1 by 2 is negative 2, negative 1 squared is 1, 1 by negative 3 is negative 3, negative c by negative 1 is plus c plus d is equal to 64. So I'm going to get here negative 2 subtract 3 is negative 5 plus c plus d is equal to 64, and therefore I can make c plus d the subject by removing negative 5, adding 5 to both sides, and we get c plus d is equal to 64 plus 5, c plus d is equal to 69. So that is my first equation. Alright, remember the objective is to establish two equations which you're going to solve simultaneously to find c and d. So once you see two unknowns, that's the first thing that should come to your mind. Alright? So let's get our second equation. It says when x minus 2 is divided into the cubic polynomial, the remainder is also 64. So we're going to create another equation by dividing this time x minus 2 into the cubic polynomial. So what we're going to say, same process. We're going to let x minus 2 be equal to 0, and therefore x is equal to what? 2. And when you substitute 2 into that cubic polynomial, you are supposed to get a remainder of 64 also. So you're going to write this as f of 2 is equal to what? 64. When I substitute 2 into that cubic polynomial, I am going to get a remainder of 64. So you have an equation here created. But to ensure that equation is visible to you, you will substitute 2 into the cubic polynomial, and we're going to get this. Substituting 2 into the cubic polynomial, I'm going to get 2 and in brackets 2 cubed minus 3 and in brackets 2 squared minus c and in brackets 2 plus d is equal to 64. Alright? So we're going to get here 2 cubed will be 8, 8 by 2 is 16. 2 squared is 4. 4 by negative 3 is negative 12. Negative c by 2 will be negative 2c. Plus d is equal to 64. Good? Let me further simplify. 16 minus 12 is 4, so I'm going to get 4. Subtract 2c plus d is equal to 64. And then I'm going to subtract 4 from both sides. So I'm going to get negative 2c plus d is equal to 64. Subtract 4, which will then simplify to become negative 2c plus d is equal to 60. Alright, so we have two equations created here. One and two. And now what we're going to do is to solve them simultaneously so we can find the c and d. Alright, so remember that's the objective. You see a question like this. You have two unknowns with a remainder factor term question. You are going to create a pair of equations and then solve them simultaneously to find those two unknown quantities. So let's solve simultaneously. This will be what? Let me do it on the side. Well, let me do it here. Let me start here. So solving simultaneously, this will be c plus d is equal to 69, and this will be negative 2c plus d is equal to 60. Good? I want to eliminate d. So I want to eliminate d. So what are we going to do? So to eliminate d, just basic simultaneous equations, I can eliminate d first. So I'm going to subtract both equations. This is equation 1, equation 2, let me subtract. When I subtract, what's going to happen? Of course, I like to put my subtraction sign in between. D subtract d is 0. That's eliminated. This will be c subtract negative 2c in brackets. Just as I see it here vertically, I write it horizontally. Is equal to 69 subtract 60. So we're going to get here a minus by a minus is a plus. So I'm going to get c plus 2c is equal to 69 subtract 60. So c plus 2c will give me 3c is equal to 69 minus 60, which will give me 9. And then to get c by itself, I'm going to divide both sides by 3. So therefore, I got my value of C as 3. So we found the value of C, and now let's get the value of D. I'm going to substitute C equal to 3 into, and you can pick any one of the original equations. I'll put it into 1, yeah, into equation 1. So equation 1, we have C plus D is equal to 69. And I'm going to replace C with 3. So 3 plus D is equal to 69. And therefore I can solve for D by subtracting 3 from both sides. So D is equal to 66. Alright? So let's make sure we familiarize ourselves with this type of question, which highly possible you can see a question like this, where you have a remainder factor term and you have to solve for 2 unknown quantities. Or you will have cases with a remainder factor term where you have to solve for 1 unknown. The objective when you have to solve for unknown quantities will be to create an equation if it's 1 unknown, or a pair of equations if it's 2 unknowns, and if it's 2 unknowns, those 2 equations you're going to solve them simultaneously to find for the 2 unknown quantities. Alright, so something to pay attention to. Alright, alright, so let's look at. Alright, we're going to get some surds. Some logarithms. There's some key things to be familiar with, and we look at some equations in index form, right? So let's look at quickly just some surds, and we start with this example here, or question. So they want us to show that the expression the square root of 25 over the square root of 45 is the same as the square root of 5 over 3. So they want us to show the square root of 25 over the square root of 45 is the same as the square root of 5 over 3. So we want to show this is equal to that. Alright, so this is where your knowledge of surds will come into play, and the whole process of rationalization as well. Right? Now, the square root of 25, this is not a surd because the square root of 25 is 5. Good? So I can write this as 5 all over the square root of 45. Now the square root of 45 is a surd because 45, that number under the square root symbol, is not a perfect square, as opposed to 25, which is under the square root symbol, is a perfect square. So hence the square root of 25 is not a surd. So a surd is where there is a square root, a non-perfect square, under a square root symbol, alright? Which makes it an irrational number. Now, so the square root of 25 is 5. The square root of 45, note surds can be reduced. We can simplify surds. So the square root of 45 can be reduced or simplified to become, so if you're simplifying a surd, you want to express the non-perfect square, which is 45, as a product of 2 factors, where one factor is a perfect square. So you want to express 45 as a product of 2 factors, where one of those factors is a perfect square. So 2 factors I can think of where one is a perfect square, that will give me 45 is 9 by 5. And 9 is a perfect square, not so? 9 is a perfect square. right? The square root of 9 will give you 3. It's a perfect square. So what I've done here, so let me further simplify the square root of 45. This becomes 5 all over. The square root of 9 by 5 is the same as the square root of 9 by the square root of 5. This becomes 5 all over the square root of 9 now, because when you have the square root of 9 by the square root of 5, just remember, you can break it up using this rule. The multiplication rule of surds. The square root of a by b is the square root of a times the square root of b. Good? So the square root of 9 by 5 is the square root of 9 by the square root of 5, which becomes 3 the square root of 5. Good? But I still do not have the square root of 25 over the square root of 45, which has been simplified to this, is not equal to this yet. Alright? So how can I make this equal to that? Okay? So the objective is to convert this into that form, to show that it's the same as the square root of 5 over 3. Alright? So to do so, this is what we're going to do. We're going to implement for surds something called rationalization. What rationalization does, it helps us to remove the surd from the denominator. See that the square root of 5 in the denominator, which is a surd. By rationalizing, it will help you to remove the surd from the denominator. So to rationalize, I'm going to rationalize now. This will be 5 over 3 the square root of 5. I'm going to multiply this fraction by another fraction whose numerator and denominator will be 3 the square root of 5. So I'm multiplying this fraction by another fraction whose numerator and denominator will be this. 3 the square root of 5 over 3 the square root of 5. Yeah? And what is going to happen here? This becomes, let's multiply, this becomes 5 by 3 the square root of 5 becomes 15 the square root of 5. And 3 the square root of 5 by 3 the square root of 5 will be 3 by 3 is 9. And the square root of 5 by the square root of 5, so 3 by 3 is 9. And the square root of 5 by the square root of 5 is the square root of 5 by 5, which is the square root of 25, which is 5. So 3 by 3 will give you 9, and the square root of 5 by the square root of 5 will give you 5. So we're going to get here 15. The square root of 5 all over 9 by 5 is 45. And therefore I can simplify that again this now, right? I'm going to say 15 into 15 is 1, 15 into 45 is 3. So that will simplify to become the square root of 5 over 3. And I can state hence show. So the right hand is shown because they asked us to show that the expression, the square root of 25 over the square root of 45 is the same as that. So they asked us to show, this is what we have done. We have shown it. Alright? So you have to ensure that you know all your laws of surds, and you can apply your laws of surds to help you to simplify expressions. And of course, your rule of rationalization is important as well. Alright, so make sure you know the rule of rationalization. Okay? So, and also rationalization as we observed. Yes, sir, to show you, maybe something like this. Let me see if I can. They may bring something like this. They may ask you to simplify 5 5 all over the square root of 2 plus 1. So they ask you to simplify something like that. You can bring that in a question, one of your questions tomorrow, where surds is involved. So to simplify that, again, always remember you never work with a surd in the denominator. So the aim is to remove the surd from the denominator. So to do so, you're going to rationalize. So how are we going to rationalize? It means we're going to multiply this fraction by another fraction whose numerator and denominator will be the conjugate. And what's the conjugate? If you have the square root of 2 plus 1, the conjugate of that, this is the conjugate. It's just simply to change the sign. It's the square root of 2 minus 1. Let's remember opposite signs, right? So that's something you have to remember with your surds. So you're going to multiply 5 all over the square root of 2 plus 1 by the conjugate, a fraction, another fraction, whose numerator and denominator is the conjugate of what is in the denominator. So this is the square root of 2 subtract 1 over the square root of 2 subtract 1. Alright? And what we're going to do now is to multiply. So we're going to multiply. Same numerator by numerator is going to be 5 times the square root of 2 subtract 1 over denominator by denominator. This is the square root of 2 plus 1 by the square root of 2 minus 1. Okay? So this will be 5 times the square root of 2 is 5, the square root of 2, and 5 by negative 1 is negative 5. Over, let us multiply these two binomials in the denominator. This will be the square root of 2 by each in the second bracket, and then plus 1 by each in the second bracket. So the square root of 2 by the square root of 2 will be the square root of 4, which is 2. The square root of 2 by negative 1 is negative the square root of 2. Positive 1 by the square root of 2 is positive the square root of 2. Positive 1 by negative 1 is negative 1. So when we simplify that, look at what's going to happen. We're going to get 5. The square root of 2 subtract 5 all over negative the square root of 2 plus the square root of 2 is 0. Those two will cancel out. And you're going to be left with 2 subtract 1, which is 1. So you no longer have a surd in the denominator. You started with a surd in the denominator, but you never work with a surd in the denominator. So you have to rationalize, and you multiply by a fraction whose numerator and denominator is the conjugate of what exists in the denominator of your first fraction. And what's the conjugate? The square root of 2 plus 1 is the square root of 2 minus 1. That's the conjugate of it. Alright, and what we have, we no longer have a surd in the denominator, and if you want, you can represent the answer as 5 the square root of 2 subtract 5. That's the final answer there. Alright, so get familiar. This is something that they can, possibly bring in the exam tomorrow when it relates to surds, so the whole concept of rationalization. Alright? Okay, let's look at question involving logs here. So we look at logs. Many students have problems with logs. So we can look at logs. Right? So let's look at a question involving logs. So they want us to solve this equation in logarithmic form. Right? And in this case, they want us to find the value of a. So we have this equation given log of, in brackets, 6 plus the square root of 12 to base 2, subtract log in brackets 3 plus the square root of a to base 2 is equal to log 10. They want us to find a, right? So we have to find a. Find the value of e. So how are we going to treat with this question in logarithmic form? So the first thing, of course, is when I look at what is on the right of the equal sign, we should understand log 10 as is. A base of 10 is understood here. It's not seen, but it is understood. So a base of 10 is understood by a log 10 there. And log 10 to base 10 is always equal to 1. Because of this important law of logarithms, log a to base a is 1. So we know that log 10 to base 10 is equal to 1. So log 10 as is the same as 1. Alright? So I write this as log 6 plus the square root of 12 to base 2 minus log 3 plus the square root of a to base 2 is equal to 1. Alright? So that's the first thing I'm going to do. Now, what we can also do is this. Now, in solving equations in logarithmic form, I'll often advise students to ensure, now log 10 to base 10 is 1, yes. But I'll always advise students to ensure that all terms are to the same base. So this is the base of 2, this is the base of 2, and this is just 1. So that is not a base of 2 yet. But we can express 1 to a base of 2. Alright? So when you're solving equations in logarithmic form, try to get all terms to the same base. So I'll write this as log 6 plus the square root of 12 to base 2, subtract log 3 plus the square root of a to base 2, and 1, if I have to express that to base 2, can be written as log 2 to base 2. Log 2 to base 2, applying this law here, log 2 to base 2 is 1. But what we have now, we have all our terms expressed to a base of 2. Yeah? So all terms are expressed to a base of 2. So that's the first thing you should do. When you're solving an equation in logarithmic form, if you get a question on logs tomorrow, make sure that all terms are expressed to the given base. In this case, to a base of 2, all expressed to a base of 2. Now, the next step is to try to get single terms on either side of the equal sign, single log terms involving logarithms on either side of the equal sign to the same base. So, single log functions, or log terms I should say, of the same base on either side of the equal sign. So if I look, I have a term involving logarithms here, one term, single term to a base of 2. I have 2 terms on either side of the equal sign here. Yes, both to the same base, but my aim is to move from 2 terms to 1 term. Because I want 1 term of log 2 on the left, 1 term of log 2 on the right. Okay, I want that. So how am I going to convert my 2 terms involving logarithms into 1? And this is where your laws of logarithms will come into play. This law will come into play. Log of a over b to bc. So this is called the quotient law. Right? And you must make sure you know your laws. This will be log of a to bc subtract log of b to base c. And the vice versa can be done. You can move from subtraction back to the quotient or division. So this here now, I can convert into one log function by simply rewriting it as log 6 plus the square root of 12 over 3 plus the square root of a to base 2 is equal to log 2 to base 2. Alright? So that now what I clearly see, I have single log terms on either side of the equal sign to the same base. Okay? So you always want to achieve that. Now that we have achieved that, what are we going to do? What we're going to do at this point is just to equate. These are called the arguments. So when you deal with logarithms, this here is normally called the arguments. What we're going to do is drop log to base 2 on both sides, and we're going to place the two arguments equal to each other. We're going to equate them. So I'm going to equate the arguments. And this becomes what? 6 plus the square root of 12 over 3 plus the square root of a is equal to 2. Alright? That is what that is equal to. Alright? What we have to do now is we'll solve that equation for a. So what we're going to do is so. We're going to, again, I have one fraction. I never solve an equation involving fractions. I have one fraction on the left. I have one fraction on the right. And to remove that equation from its fraction, where you have no more fractions involved, you can simply carry out cross multiplication. Yeah? So you're going to multiply 2 by 3 in brackets plus the square root of a is equal to, you're going to multiply 1 by 6 plus the square root of 12. Yeah? And therefore, this becomes, in removing brackets, 2 by 3 is 6, 2 by the square root of a is 2 the square root of a is equal to 6 plus the square root of 12. Yeah? You can subtract 6 from both sides, you're going to get 2. The square root of a is 6 plus the square root of 12, subtract 6. And therefore, these two 6's will cancel. You're going to get 2 the square root of a is equal to the square root of 12. Yeah? And the square root of 12, again, this is why surds are so important. The square root of 12, it is a surd which can be simplified. This is the same as 2. The square root of a is equal to, simplifying that surd, this is the square root of 4 by 3. So you're going to get here 2. The square root of a is equal to the square root of 4 times the square root of 3. The square root of 4 times the square root of 3. So this becomes 2 the square root of a is equal to 2 root 3. And what you can do now is remove the 2 in front of the square root of a by dividing both sides by 2. And what you do to one side, you do to the other. You're going to divide 2 the square root of 3 by 2 as well. So when these two 2's divide into each other to give 1, these 2 divide into each other, you're going to be left with the square root of a is equal to the square root of 3. And you want to remove the square root symbol from a. So to remove that square root symbol from a, what you're going to do is basically square the square root of a. But if you do it on one side, you must do it to the other. You can't do it on one side and leave out the other. So when you square the square root of a, that will help you to remove the square root symbol. That becomes a. Alright? Remember, the square root of a is the same as a to the power of a half. That's the square root of a. The square root of a is equal to that. So if you have the square root of a to the power of a half all squared. A half by 2 is 1, so you'll end up with a. Not so? And if you do it to one side, you have to do it to the other. You can't just square one side and not square the other. So the square root of a all squared becomes a. And the square root of 3 all squared is the same as 3. So a is equal to 3. So this is solving this equation in a logarithmic form. Remember, the aim is to get all terms in your logarithmic equation all to the same base. So in this case, if this is 1, this is log 2 to base 2. So I have all terms to the same base, and I worked towards getting a single log function on the right, single log function on the left. And once you do so by applying the laws of logarithms, we can equate the arguments, which will be this and this, equate them, create an equation, and solve for a. Alright? So that's going through. Now, so this is something we also have to be aware of when it comes to logs also. Let me erase here. Alright, so going through some key topics that you often see in the exam, and you know how we will treat with solving questions in relation to those topics, alright? Alright, so you can see a linear law, right? So sometimes they like to bring this, it's under logarithms, yeah? An equation relating v and t is given by, so we have v is equal to ka to the power of t. So we have that, where k and a are constants. Right? So let's be conscious of this, converting from a non-linear form to a linear form. Good? They want us to use logarithms to derive an equation of the form y equal to mx plus c that can be used to find the values of a and k. Alright? So we want to convert this non-linear into a linear form. And to do so, we're going to apply our laws of logarithms. Okay? To help you. So to do so, to convert this from non-linear to linear, we're going to find the log of both sides. Log of v is equal to log of ka to the power of t. So that's the first thing you do. So you find the log of both sides. And after you find the log of both sides, then what you're going to do on the right, you're going to apply your product law to help you to get to the form y equal to mx plus c. So this will be log of v is equal to log of k plus, remember what's the product law? The product law is this, log of a multiplied by v to base c is equal to log of a to base c plus log of b to base c. Remember that, that's a product law, right? So you're going to use the product law to break this up into log of k plus log of a to the power of t. And therefore this becomes log of v is equal to log of k plus t log a. Alright? So now we have it in the form, if you look, we have it in the form what? Y is equal to y is equal to mx plus c. So the gradient here will be, well, it depends, it depends on what they want us to place on the x-axis and on the y-axis, okay? So in this case, the y-axis could be log v, and the x-axis can be log a, and the x-axis is log a. So this, log v is on the y-axis. To get it in the form, we have to, of course, use logs. So once we have it in the form, y equal to mx plus c, this will no longer be the y-axis, but the log v-axis. And let me see if the graph of y versus x on the equation in C part 1 is plotted. A straight line is obtained. State an expression for the gradient of the straight line. Yeah? Okay, so what we can do, or if not, if log A was x, then it means t will be the gradient. Alright, so you have a line sloping, t will be the gradient. Or you can have log v as the y, and you can have t as the x. Yeah? And therefore log a would have been the gradient. Right, so it all depends on what they want you to place on the y-axis and on the x-axis. Yeah? Right? So, in this case we have log v, which is y, is equal to mx. So I'll consider m to be the gradient t, and x to be log a, and of course c will be log k. So we have it in the form y equal to mx plus c. So that's something we have to pay attention to, right? Because you can see a question like this, conversion to linear, in your exam tomorrow, where they give you a non-linear form and they ask you to convert it into a linear form. Alright? And this is what we do to convert it into a linear form. Alright? Alright, okay, let's also pay attention to this kind of equation as well. This is an equation in index form. So we brought this last year. And it's highly possible we can bring it again this year. Right? We have this one here very similar to it. Alright? So I'll do the one from last year. Right, then we'll jump into some quadratic equations, right? I'll probably do one more solving equations in logarithmic form, and then we jump into quadratic equations. So, they want us to solve this equation. Solve 3 to the power of 2x plus 1 minus 5 into 3 to the power of x, subtract 2 is equal to 0. Alright? So this is an equation in index form. And you know, normally when you're solving an equation in index form, what you try to do is you try to get single terms on either side of the equal sign to the same base. So for example, if I have 4 to the power of t is equal to 8, for example. Both are not to the same base, but and this is an equation in index form, but I can make both to the same base because 4 is the same as what? 2 squared to the power of t, 8 is the same as 2 cubed. So I can write this as, I can multiply t by 2 by the law of power to power for indices. T by 2 is 2t, so I have 2 to the power of 2t is equal to 2 to the power of 3. And once I have the same base, I can place my powers equal and hence solve for t. So this is a simple equation in index form, and we always try to get single terms on either side of the equal sign to the same base. But you see this equation? This is also an equation in index form. But there's no way we can make this happen. No way you can simplify this to get terms, single terms on either side of the equal sign to the same base. You can't convert 5 to a base of 3. Alright? Neither can you convert 2 to a base of 3. And there's no law of indices for subtraction. There's law of division, there's law of multiplication, but there's no law of subtraction. So there's no way this can be represented in this form. Alright? So what we have to do to solve that equation is use a method of substitution which will help us to create a quadratic equation. And then we'll use a quadratic equation to help us to find what is required. Alright? So, how are we going to use this method of substitution to create a quadratic equation? You see the 3 to the power of x here. We're trying to get as many 3 to the power of x as possible in this equation. I'm clearly seeing 1 here. I can also get 1 from this 3 to the power of 2x. That 3 to the power of x can also be obtained somewhere here. And how are we going to make that happen? 3 to the power of 2x plus 1 is the same as 3 to the power of 2x times 3 to the power of 1. For my law of multiplication of indices. When you have the same, look at how this will go back to this. When you have the same base and the multiplying, you maintain the base 3 and the powers you add. So this 3 to the power of 2x plus 1 can be represented in this form or can be broken up into that form. 3 to the power of 2x times 3 to the power of 1. Both are the same. Subtract 5 into 3 to the power of x, subtract 2 is equal to 0. I'm still not seeing, I'm still only seeing 1 3 to the power of x. So how can I get another? Again, focusing here. 3 to the power of 2x can be rewritten as 3 to the power of x in brackets squared. Yeah? So 3 to the power of 2x can be written like that. 3 to the power of x in brackets squared times 3 minus 5 into 3 to the power of x in brackets minus 2 is equal to 0. Right? But you know what this is here? This is a quadratic equation. You may not see it right away. You're watching that and saying, how does a quadratic equation? That is a quadratic equation when we introduce this method of substitution which will make the quadratic equation very clear to you. If you let, this is where you're going to use the method of substitution. Y, if you use y on the letter of the alphabet, be equal to 3 to the power of x. You let y be equal to 3 to the power of x. Where you see 3 to the power of x in that equation, you're going to replace it with y. So this becomes y squared times 3 minus 5 times 3 to the power of x is y minus 2 is equal to 0. Y squared by 3 becomes 3y squared minus 5y minus 2 is equal to 0. And what we have there now is a quadratic equation that we can solve. When we solve it, we're going to solve for y, but then remember the aim of this question is not to solve for y, it is to solve for x. So then when we solve for y, what are we going to do to find x? And this is what we're going to see as we proceed when we get the two values of y after solving this equation. So let's solve this equation to get two values of y. So I'm going to factorize this expression. 3 by negative 2a by c will give me negative 6. I want two factors of negative 6. When multiplied will give me negative 6. But when added or subtracted can help me to get my middle term, negative 5y. The two factors of negative 6 I can use are negative 6 times positive 1. Negative 6 by positive 1 gives me negative 6. But negative 6 attach y to it becomes negative 6y. And positive 1 attach y to it. Negative 6y plus 1y will give me negative 5y. My middle term achieved. And once I achieve my middle term, I'm going to rewrite this expression now as 3y squared I'm replacing negative 5y with negative 6y plus y minus 2 is equal to 0. And what I'm going to do is to factorize the expression on the left, because I have 4 terms, so I can carry out my method of grouping. So this becomes 3y squared. So I'm going to pay off. Let me write it on this side to create some space. 3y squared plus y. 3y squared, sorry, minus 6y plus y minus 2 is equal to 0. Let me pay off. What is common to my first pair? Clearly, 3y is common to my first pair. I take it out as a factor. And now let me divide 3y into 3y squared gives me y. And 3y into negative 6y gives me negative 2. Let me factorize my second pair. The sign controlling the first term of the second pair, which is this plus sign, I bring down automatically. That's automatically a part of my highest common factor. There is no other factor common to y and negative 2, but what is understood after this plus sign is 1. So let's divide. So plus 1 is the highest common factor. Let's divide plus 1 into plus y to give me y. And let's divide plus 1 into negative 2 to give me negative 2 is equal to 0. I have the same thing in brackets, so I now can factorize further. So I take out y minus 2, which is common to both, and 3y plus 1 will be placed in the other bracket. And of course, I'm going to solve for two values of y. I'm going to say either y minus 2 is equal to 0, y is 2, or 3y plus 1 is equal to 0, 3y is equal to negative 1, and y is equal to negative a third. But remember, you're not solving for y, you're using this quadratic equation to help you to find your values of x, value or values. So we use a substitution approach to help us to clearly see our quadratic. We solve for y, but now let's bring back x into the equation so we can find values of x. That's what you're solving for, the equation starting with x. That's what you have to solve for, right? So how are we going to bring x back into our equation to find x? Y, we stated that y be equal to 3 to the power of x. So this y equal to 2 can also be written as, so y equal to 2 is the same as I'm replacing this y with 3 to the power of x. 3 to the power of x is equal to 2. So bring back in my 3 to the power of x. And now let me solve for x there. Now that is a simple equation in index form. We cannot get the bases on either side of the equal sign to be the same. There's no way that can happen. So how am I going to solve that equation for x? This is where I'm going to introduce the logs. So to get x by itself, I need to find the log of both sides so I can solve for x. So the only way you can solve for x is to use logs. So I'm going to find the log of 3 to the power of x. I put log in front of 3 to the power of x, and I'm going to put log in front of 2. You can write log if you want, right? And then the x, I'm going to use my power law now. The x, which is the power of 3, will be placed in front of your log notation. So this becomes x log 3 is equal to log 2. And therefore, to get x by itself, I need to remove log 3. So to remove log 3, I'm going to divide both sides by log 3. So this is x log 3 divided by log 3. And what you do to one side, you do to the other. You divide log 2 by log 3. So when you have two log 3s divided to each other to give 1, x will be equal to log 2 divided by log 3. That will be your value of x for your either. That's log 2 divided by log 3, which will be 0.63, right? So that's the value of x we got for either. What about the or now? Let's do the or. I'm going to replace this y in my y equal to negative a third with 3 to the power of x also. So let me get some, let me just write it on top here. So this y equal to minus a third. I'm replacing that y with 3 to the power of x as well. But negative a third, we can rewrite that, put it in index form, take the 3 from the denominator, move it to the numerator, and change the sign from positive 1, which is understood by 3 there, to negative 1. So this is positive 1 here. So when I move it up to the numerator, it becomes negative 3 to the power of negative 1. Negative a third is the same as that, right? But in this case, there's no way that's a base of 3 and that's a base of negative 3. So you can't say let me equate the powers. Those two bases are not the same. Alright? They are not the same. Alright? And even if you said, alright, 3 to the power of x is equal to negative a third, let me use the logs. You cannot use the logs there either. Because you can't find the log of a negative a third. You can't find the log of a negative number. That is undefined. So in this case, we cannot find a value of x, and therefore we're going to state no solution. So there's no way we can get the same base on either side, and there's no way we can use logs. This will be no solution here. So your answer for x in solving this equation will be 0.63. Yeah? That's your answer. Okay? So make sure that we're clear on these equations in index form, where the whole method of substitution, creating quadratic equations, can come into play to help you. Alright? Alright, I'll just do one more equation in log form. I'll do this one here, and then we'll solve an equation in then we'll jump to quadratic equations, right? So we do some quadratics, let's see. Right, let's look at this equation. Making sure you see a question, we have to solve the equations in a logarithmic form. We can do so comfortably, right? Alright, so let's solve that equation. We want us to solve the equation log of x plus 1 plus log of x minus 1 is equal to 2 log x plus 2. So we have to solve that equation in logarithmic form, right? So how are we going to solve that equation? So the first thing is to make sure all terms are to the same base. Base of 10 is understood, it's not seen but it's understood. Base of 10 is understood, base of 10 is understood. All are to the same base. Then what we want to do, we're looking to see whether the laws are applicable, because what we want to achieve is a single terms on either side of the equal sign, single terms, log terms, on either side of the equal sign of the same base. We have 2 log terms on the left, we have 1 log term on the right. So we have 1 log term here, but we need to convert these 2 log terms into 1. Alright? But the only thing is, you have to be careful on the right. This 2 log x plus 2, remember this important law. This is known as the power law. Log a to the power of beta base c. This power b can be placed in front of your log a to base c. Alright? That's your law. You can place this b in front of your log a to base c. That's called the power law. And the vice versa can be done. You can move from here back to here. So what I'm seeing here, this 2 in front of my log function, I'm going to place it at or as the power of x plus 2. So this becomes log of x plus 2 to the power of 2. Alright? So that's the first thing I should do with the right side of the equal sign. On the left side of the equal sign, what I'm going to do is implement now my product law to move it from 2 terms involving logarithms to 1 term involving logarithms. So this will be log, we know log of a by beta base c is a log of a to base c plus log beta base c. So let me do the reverse. This log of x plus 1 plus a log of x minus 1 can now be written as a log x plus 1 x minus 1. So I apply my product law. Now what we have? Single log terms on either side of my equal sign. Both to the same base. I want to have single log terms on either side of the equal sign of the same base, then you can equate the arguments. You can put those two equal to each other. So when I get x plus 1, x minus 1 is equal to x plus 2 all squared. Okay? Making sure we can solve our equations in logarithmic form. Where I strongly believe that you can see a question like this tomorrow. Alright? So what are we going to do? Let's solve it. So we're going to expand. This is, I'll be writing as x plus 1, x minus 1, x plus 2, x plus 2. So in expanding, what are we going to get? This becomes x by x by negative 1, 1 by x, 1 by negative 1. So x by x will give me x squared. X by negative 1 gives me negative x. Plus 1 by x gives me plus x. Plus 1 by negative 1 gives me negative 1. Is equal to, let me expand what is on the right. So x by x gives me x squared. X by plus 2 will give me plus 2x. Plus 2 by x will give me plus 2x. And plus 2 by plus 2 gives me plus 4. So this will now simplify to become x squared, negative x plus x is 0, minus 1 is equal to x squared, 2 plus 2x plus 2x is 4x plus 4. Good? If I decide to put everything over on one side, on the left side, this becomes x squared, subtract 1, positive x squared comes across as negative x squared, plus 4x comes across as negative 4x, positive 4 comes across as negative 4 is equal to 0. And therefore, what's going to happen here? My x squared subtract x squared, those two will cancel out as 0. I'm going to have negative 1 subtract 4 is negative 5, so negative 4x, negative 4x, negative 1 subtract 4 is negative 5, is equal to 0. And therefore, what we're going to do? We're going to remove that negative 5 by adding 5 to both sides. And then to get x by itself, I'm going to divide both sides by -4. So the answer for x in this equation in logarithmic form is -5/4. Or 5/4. Or if you want to write it like this. -5/4. Alright? But what is key here is making sure you get single log function, single log terms, of the same base on either side of the equal sign. You use your laws to help you to do so. Alright, so well, let's look at our quadratic equations. All right, so right, so I'll start off with a question on types of roots. Make sure you know types of roots. Then we're going to also do irrational inequality. Make sure we can treat with questions involving rational inequalities. Also, let's see if I have any here. Right. We also want to solve a quadratic inequality. That's important. Make sure we can complete the square, because you know they love to bring that. Alright, yeah. So let's look at this here. So looking at types of roots, right? So we want to make sure, remember our types of roots. So remember there are 3 types of roots. You have real and distinct roots. You know b squared minus 4ac is greater than 0. You have real and equal roots. We know b squared minus 4ac is equal to 0, and you have imaginary roots. We know b squared minus 4ac is less than 0. Okay? So in this question it says, determine the values of p for which the function px squared plus 3x plus p has 2 real distinct roots, given your answer in its simplest form. Real distinct roots. Okay? To determine the values of p. So we have here so this here should be a quadratic equation. Alright, we have variable squared equal sign and 0. So a quadratic equation there, even though it wasn't stated as a quadratic equation. So we have our quadratic equation, and it's stated that the roots of that quadratic equation are real and distinct roots. So for real distinct roots, you know this will come into play. Yeah? So for real distinct roots, we know b squared minus 4ac is greater than 0. We know that. Good? And what we need to do is to identify what is A, B, and C so we can substitute it into what we call our discriminant. Alright? So what is A? A is always a number, what in this case variable, in front of x squared, which is P. B will be always what exists in front of x, which is what? 3. And C is your constant. So any term that is does not have that is not a coefficient of x or x squared is considered a constant. So for example, 3 is the coefficient of x. P is the coefficient of x squared. 2p has no x or no x squared attached to it. Yeah? So therefore 2p is considered your constant, which is C. So once I know that, let me substitute now into my discriminant. So I'm replacing b with 3 in bracket squared minus 4a is what? P. C is 2p is greater than 0. This becomes 9 minus 4 by p is negative 4p. Negative 4p by 2p will give me negative 8p squared is greater than 0. Good? Remember, they want us to determine the value or values. Alright? So it can be one value of p or more than one value of p. Right? So value of values. So this here is what we call a quadratic inequality. And let's make sure we know how to solve a quadratic inequality, because they can very well bring a quadratic inequality in the exam for you tomorrow. So make sure you know how to solve your quadratic inequalities. Question 2, section 1. So, how we solve a quadratic inequality? You need to get your roots first, and then you have to sketch to get your range. You're not going to solve this like a normal quadratic. You're not going to maintain this inequality symbol throughout and solve for p and no, that's not the approach. The approach is like this. You have to get your roots first and then sketch to get your range. So this is what you're going to do. You're going to let 9 minus 8p squared be equal to 0. So you let a quadratic expression be equal to 0 first. Let's solve for our values of p. Now this cannot be factorized, so I have to get my values of p by first removing positive 9. It comes across as negative 9. And then what I'm going to do is to remove negative 8. So I'm going to divide both sides by negative 8. So my two negative 8's divide into each other. I'm going to get p squared is equal to 9 all over 8. Then to get p by itself, I need to find the square root of 9 over 8. But I'm going to put a plus or minus sign in front of the square root symbol, because when you find the square root, you must consider both positive and negative results. So p will be plus or minus the square root of 9 over 8. Let me work that out one time so you can write it as a decimal number. Second function, square root, brackets, by 1.06. So my two values of p are either p is equal to positive 1.06 or p is negative 1.06. These are my two values of p. But what I have to do now is to Those are your roots. But to get the range of values of p now, this is where you have to sketch. So you have to sketch a quadratic function, and it's not a detailed sketch, but you have to use that sketch to define your range. So to sketch, what do? When we look at the quadratic inequality we are solving, the quadratic expression is one whose number in front of x squared is negative, or variable squared, p squared in this case, it's negative. So because the coefficient or the number in front of p squared is negative, when I'm sketching, my curve will be like that, concave down. So when you're sketching, of course, you make sure you recognize if the curve is concave down or concave up. So the number in front of, or the coefficient of your variable square will identify that. So your roots here are negative 1.08 and positive 1.0, not 06, not 08, sorry, negative 1.06 and positive 1.06. Those are your roots. Good? And where does the range of values lie? The range of values will be dependent upon your inequality symbol. So if it's greater than means you're looking at the region above the x-axis. So this is my x-axis here. Above the x-axis, this will be my satisfied region, the belly of the curve. I like to call it the belly of the curve. Any number within that range will satisfy this inequality. So that is my satisfied region. So to find your range of values of p, knowing that your satisfied region lies between negative 1.06 and 1.06, you'll state your range of values that will satisfy this inequality as p is greater than negative 1.06 and p is less than 1.06. Alright? And anytime it falls within the belly of the curve like this, also remember you can collate your answers. So instead of leaving it like that, you can bring them together. So you can write this as p is less than 1.06, what I have on that side, leave it as is. And if p is greater than negative 1.06, it means negative 1.06 is less than p. And that is correlating the two inequalities, and this can only be done if it falls within the belly of the curve. The range of values fall within the belly of the curve. Alright? So this is how you solve a quadratic inequality. This is a quadratic inequality, and this is how we solve it. You have to get your roots first, then sketch to find your range of values. So you have to sketch to get the range of values. So remember that. And if the number in front of the variable square is negative, the curve is concave down. If it's positive, the curve is concave up. And you use the inequality to determine where the range of values lie. So in going through quadratics, we will encounter another quadratic inequality. And let's make sure we know how to solve a quadratic inequality, alright, to get the range. So for sure in question 2 tomorrow, section 1, I'm sure you're going to see a quadratic inequality. Let's look at this. This is another common, because you might see this tomorrow too, very possible. Right, let's make sure we can write a rational inequality. You should treat with questions like those, right? So you see that in the exam tomorrow, you realize easy marks in the back. So let's look at that. So, if you have 2 minus x, or just to determine the values of 2 minus x over 4x minus 9 is less than 0. That is called a rational inequality. We should know how to solve that. Okay? You see that in question 2, section 1. So to solve a rational inequality, again, you never work with the rational. So you have to remove the rational first. So to remove the rational, you can multiply both sides by the square of the denominator. So the denominator square. So multiplying this side by the denominator square is less than you multiply what is on this side by the denominator square. So 4x minus 9 into 4x minus 9 squared gives you 4x minus 9. So you're going to multiply 4x minus 9 by 2 minus x. So you get 4x minus 9. 2 minus x is less than 0 by 4x minus 9 all squared is 0. So you have no more fractions. So you remove it from the rational. A rational is a fraction, right? That's why they call it rational inequalities. So you remove the fraction. And what you have here is a quadratic inequality like what we just did, right? This is a quadratic inequality. And with quadratic inequalities, the first thing you have to get is your roots. You're not going to treat this like a normal quadratic equation and put this less than 0 and get values of it and then put that less. No, you're not doing that. What you're going to do is to start off by stating this. Let 4x minus 9 and 2 minus x be equal to 0. That's how you're going to start. You're going to get your roots first. And then you're going to say either 4x minus 9 is equal to 0, 4x is equal to 9, then I divide both sides by 4. So x is equal to 9 all over 4. So that will be one root. 9 over 4 is the same as 2 1/4. Or my other root will be 2 minus x is equal to 0. I can take this negative x and bring it over on the right hand side. So I get x is equal to 2. So that's the other root. So one root is 2 1/4, the other root is negative 2. After you have found your roots, then you are going to use your sketch to find your range of values. Okay? Now, how is this sketch going to look? Now, this is the quadratic inequality. For us to determine how the sketch will look, let's just expand this quickly so you can see what number exists in front of x squared. But if you expand it, what you're going to get? You're going to get 4 by negative x is negative 4x squared. So you see the number in front of x squared is negative. So you know your curve is concave what? Down. Alright? So when you expand this 4x let me expand it so you'll see it. 4x by 2 is 8x. 4x by negative x, negative 4x squared. Negative 9 by 2, negative 18. Negative 9 by negative x plus 9x. So you'll get what? You'll get negative 4x squared plus 17x minus 18, right? So that is the quadratic inequality. This here, when expanded, of course, will become this. But there was no need for us to expand to solve, right? So all we had to do was use the two binomials, put it equal to 0, we'll get you two values of x. No need to expand. The reason why I did this little expansion on the side here is for us to recognize if our curve is concave up or concave down. So the number in front of x squared is negative, so I know my curve is concave what? Down. Good? And my roots are 2 and 2 1/4. So 2 is smaller, so it will be on the left, and 2 1/4 is bigger, so it will be on the right. And my range of values, of course, I'm dealing with the inequality symbol less than. Less than means you are looking at the region below the x-axis. This is my x-axis here. The region below the x-axis will lie where? Not within this belly of the curve, right? The mouth of the curve is open, so when that happens, you shade external. Any values less than 2 will satisfy this inequality. Any values greater than 2 1/4 will satisfy this inequality. The range of values that satisfies the inequality will be less than 2 and greater than 2 1/4. So how do you write your answer? You write your answer as this. X is less than 2, and anytime it falls external, this is the mouth of the curve, I call it the mouth, external, you're going to use the word or. X is greater than 2 1/4. So x is less than 2 or x is greater than 2 1/4. And that's a range of values. Alright? So those are a range of values of x. We're not going to collate them, huh? We only collate when it falls within the belly of the curve. So this here is a rational inequality. You want to make sure you know how to solve, right? All right. Let's look at quickly. Right, let's look at quickly. That's clear to the eye. Alright, let's look at quickly. Completion of squares. Another quadratic inequality, and after that we'll jump into one or two questions, roots involving alpha and beta, and we'll do a simultaneous of a linear and non-linear, and then we'll do some, there's one or two APGPs, and then we'll jump into some circle terms. I'll try to see what I can do because I'll end at 12 o'clock, right? So let's see what we can do in the next hour. Okay, let's see how many things we can get through it. Alright, so alright, so you know you're going to see, let me see if I get a better, right. Question looks better. Alright, so you know you're going to see completion of squares in your exam. For the past 3-4 years you have been seeing completion of squares. Let's hope that they bring it tomorrow, most likely they will. So you know if you have to complete this square, let's make sure we can all complete this square and get those marks, alright? So if we have 3x squared minus 9x plus 4, f of x is equal to that. And they ask us to convert it into the form a into x plus b all squared plus c. Remember they asked you to represent it in that form. Pretty straightforward. We know that we can use the formula approach. So there's a formula for b, which we sometimes write as h, and c, which we sometimes write as k. Good? So we know that to do so, a is 3. We state this first. B is negative 9. C is 4. We know b is the same as h. And that can be found by using the formula b over 2a. B will be negative 9 over 2 times a, which is what? 3. Negative 9 over 6, which is negative 3 over 2. That's your B or H. C, which is K, is 4AC minus B squared over 4A. 4 times A, which is 3. C, which is 4 in brackets. Subtract negative 9 in brackets squared all over 4 times A, which is 3. So what are we going to get? 4 by 3 is 12. 12 4s are 48. Subtract. So don't say a minus or a minus or a plus. You pull the subtraction sign. You square negative 9, which is positive 81, all over 12. So you're going to say 48 subtract 81 will give us what? So 48 subtract 81. That's negative 33, all over 12. And once you have done that, then you can, once you have found A, B or H, and C, which is your K. Remember, this B is not this B here, that C is not that C here. This B is the same as the H, your custom seal. That C is the same as the K, your custom seal. So this will be 3x squared minus 9x plus 4 will be the same as A, which is 3, into x. Your B will be minus 3 over 2, in brackets squared, minus 33 all over 12. So that's completely squared. Alright? Then they ask the minimum point of f of x. What's the minimum point? So remember the minimum point is, this is part B. The minimum point is always equal to, or the turning point, whether it's maximum or minimum, the turning point is always denoted by the equation of axis of symmetry, which is the x coordinate of the turning point, denoted by negative h, and the y coordinate of the turning point denoted by k. Negative h will be this b here, which we always refer to as h. So negative h will be to put that negative sign in front of negative 3 over 2. So if I put that negative sign, this is my h, negative 3 over 2, then that becomes positive 3 over 2. So that will be the x coordinate of the minimum turning point. And the y coordinate of the minimum turning point is always k. So that negative 33 all over 12. So the coordinates of your turning point will be positive 3 over 2 and negative 33 over 12. So that's the coordinates of your turning point. Alright? Alright, so we know we have roots involving alpha and beta. So I'll just show you that quickly, and then we will jump into 1 or 2 questions on APGPs, and we jump to section 2. Look at an equation of a circle of vectors, a sector and a trig, and see if we can do a bit of differentiation and integration. So quickly we can get something done there, right? So let's look at the roots involving alpha and beta. Right, so remember, if you have, let me put this, let me get one that, always bring that common one. Let me get one like this. So I feel like I bring one like this tomorrow. If they bring it out, it's involving alpha, one like this. That 1 over alpha squared plus 1 over beta squared. That's something that they can bring. So if we have this here, if alpha and beta are the roots of the equation, 2x squared minus 5x plus 3 is equal to 0. Determine the value of 1 over alpha squared plus 1 over beta squared. You want to find the value for that. Good? So how are you going to find a value for that? The first thing you do is identify what is A, B, and C. A is 2, B is -5, C is 3. Good? Then, because you're dealing with alpha and beta, you have to ensure you know first the sum of the roots, which is minus B all over A. That will be minus B is -5 in brackets all over A, which is 2. So you get positive 5 over 2. That's the sum of the roots. The product of the roots you also have to know alpha beta. That is equal to C all over A. C will be 3 and A is 2. So make sure you know the sum of roots and product of roots. Then you want to simplify this expression where both sum of roots and product of roots are easily recognized. So you're going to simplify this expression. First thing, you're adding two fractions, so you have to find the LCM first. The LCM of alpha squared beta squared is alpha squared beta squared. That's the LCM. Good, one of each. Alpha squared into alpha squared beta squared will give you beta squared. Beta squared by 1 will give you beta squared. Plus, beta squared into alpha squared beta squared will give you alpha squared. Alpha squared by 1 will give you alpha squared. Yeah? Now you need to know, and this is very important, you need to know what is alpha squared plus beta squared. So let's often try to memorize it and make sure you memorize it, right? Alpha squared plus beta squared is this. Alpha plus beta all squared minus 2 alpha beta. Just remember that. That is what alpha squared plus beta squared is equal to. Yeah? So in your numerator, you're going to write alpha squared plus beta squared as that. Alpha plus beta all squared minus 2 alpha beta. But you can clearly see the sum of the roots and the product of the roots. Good? Over alpha squared beta squared. Alpha squared beta squared is the same as alpha beta all squared. That is what that is equal to. So I'm going to replace alpha squared beta squared with alpha beta all squared. So what I'm going to do is substitute. I'm going to replace alpha plus beta with 5 over 2, alpha beta with 3 over 2, right? See them both numerator and denominator. Good? And then work it out to get my result for 1 over alpha squared plus 1 over beta squared. So this becomes what? This becomes alpha plus beta is 5 over 2 in bracket squared, subtract 2 times alpha beta is what? 3 over 2 1 over alpha beta squared, that's 3 over 2 all squared. So 5 over 2 squared, that's the same as what? 25 over 4. Subtract 2 by 3 over 2 is 3. Over 3 over 2 squared, that's 9 over 4. So 25 over 4, subtract 3 over 1. LCM 4 into 4 is 1, 1 by 25 is 25. 1 into 4 is 4, 4 by 3 is 12. So you're going to get 13 all over 4. So this will be 13 all over 4 divided by 9 over 4, which is the same as 13 all over 4 multiplied by 4 over 9. So change division to multiplication input. So you're going to get here 13 all over 9 will be your answer. Or 1 and 4 ninths. Alright, so that's the answer for 1 over alpha squared plus 1 over beta squared. So you should know your roots involving alpha and beta, right? Sum of roots, product of roots. Formula for sum, formula for product, and of course when you simplify the expression, make sure you know what is alpha squared plus beta squared. Alpha plus beta all squared minus 2 alpha beta. Don't forget that, alright? Okay, let's quickly look at, right, let's have APGPs first. Right, I'll do this one quickly. Right, so I'll do an APGPs where sometimes they can ask you to solve for both, if it's a GP, A and R, and AP, A and D. So look at that quickly, right? Alright, let's look at that, and then we jump into equation of a circle. So try to see if we can get to some differentiation integration before 12 o'clock, right? Alright, so an accountant is offered a 5-year contract with an annual increase. So every year he is going to get an increase. The accountant earned a salary of $53,982.80 and $60,598.89 in the third and the fifth years respectively. If the increase follows a geometric series, calculate the amount paid in the first year. Alright? So this is a case where you have this accountant is offered a 5-year contract. 1, 2, 3, 4, 5. 5-year contract. Good? And the accountant earned a salary in the third year of $53,982.80. Good? And in the fifth year, he earned $60,598.89. Good? If the increase follows a geometric series, calculate the amount paid for the first year. How much is paid for this first year? Okay? And it follows a geometric series. So you have to know what is A, and you have to know what is R. Now with the common ratio, always multiply by each term by the previous term to get the present. Good? So the GP is about multiplying that constant throughout. Alright? So we need to get A and R. So of course, once we know R, then we can find A, the first term, how much is paid, how much he was paid in his first year. So to find A and R, we need to establish two equations. So this information, these two pieces of information here, will help us to find our two equations. So in the third year, he's paid $53,982. For GP, please make sure you know the formula for the general term. This formula here will help us to determine the value for a particular position. So if it's the fifth term, you can use this formula to determine what's the value. If it's the third term, you can use this formula to determine what's the value. Alright? So we know that our third term, which is the third year, from this question, is $53,982.80. We know that the fifth term is $60,598.89. Good? So creating two equations here. Now the third term will be, I'm replacing n with 3. So this will be AR to the power of 3 minus 1, which is AR squared, is equal to $53,982.80. And the fifth term and replace it then with 5, that's AR to the power of 5 minus 1, which is AR to the power of 4, is $60,598.89. So what you have here are two equations, equation 1, equation 2. Now when it comes to GPs, for you to find R and then find A, you always divide the present by the previous. The present, of course, will be the 5th, and the previous will be the 3rd. So you're going to divide, always divide 2 by 1. Equation 2 by equation 1. That's what you're going to do when you are dealing with the GP, right? So you're going to divide equation 2 by equation 1. So you're going to put AR to the power of 4 equal to $60,598.89 over AR squared. You're going to put this $60,598.89 over $53,982.80. So what is going to happen here? The two A's will cancel out. R to the power of 4 divided by R squared will give you R squared. And it's $60,598.89. When you divide that by $53,982.80, you're going to get R squared is equal to 1.122559223. And therefore, to get R by itself, you have to find the square root of both sides. So R is the square root of 1.122559223. And the square root of that will give us what? 1.122559223. Right, we're going to get 1.06. So that there is a common ratio. And after you have found the common ratio, then let us find the first term. I'm going to substitute R equal to 1.06 into any one of my original equations, but I'll put it into the easier of the two, which is equation 1. So I'm going to substitute R equal to 1.06 into equation 1. So I'm going to get here equation 1 is AR squared is equal to $53,982.80. So I'm going to replace my R with 1.06. It becomes A into 1.06 all squared is equal to 53,982.80. So 1.06 all squared, that's 1.06 by 1.06. Right, so A, this is 1.1236A is equal to $53,982.80, right? So to get A now, I'm going to divide $53,982.80 by 1.1236. So what will be my first term? What will be the amount of money paid for the first year to this accountant? Right? It's going to be $48,044.49. Alright? So that's how much he's going to be paid. That's your first how much he received in his first year. Alright? And okay, so what's the total salary earned at the end of the contract? So let's determine what the total salary earned. So when you talk about total salary, we are talking about what is the total amount of money he earned for this 5-year contract. Total amount of money, total, that means we're going to use the sum of a GP. Sum of a GP. Okay? So, with the second part, what is the total salary earned at the end of the contract, 5-year contract. So the 5-year contract, total salary sum of all the money earned. So this will be what? Right, let's make sure I write R on this side. So I remember what R is equal to, right? Let's remember, what is the sum to n terms of a geometric progression? So the sum to n terms of a geometric progression is A into, now because the common ratio is greater than 1, remember the formula you use, A into R to the n, subtract 1 over R subtract 1. This is when R is greater than 1. If the common ratio is less than 1, you use this. A into 1 minus R to the n over 1 minus R. So when R is less than 1, common ratio is less than 1. So because the common ratio is greater than 1, this is the formula we're going to use. So let's get the sum of all the money earned by this accountant for this 5-year period, this contract for 5 years. So A is $48,044.49. R is 1.06. N will be the number of years, which is 5 years. Subtract 1 in brackets. Over R, which is 1.06, subtract 1. So this becomes what? This becomes S is equal to 48044.49, 1.06 to the power of 5. Let me subtract 1. So I'm going to get 0.338225577 over 1.06 subtract 1, 0.06. So this is 48044.49 times 0.338225577 divided by 0.06. Right, so the total amount of money this accountant earned at the end of his 5-year contract will be $270,831.26. That's the total amount of money he earned for the 5 years. Alright? So this here class is a GP, geometric progression. And make sure you know how to treat with it, alright? What I'll do, I'm going to jump to the equation of a circle. Let me deal with that. Make sure you know how to treat with the equation of a circle. We'll do our vectors. And we'll do a sector and a trig. Let me see if I can do a bit of a differentiation and integration. Try to end by 12, right? Okay, so, alright. So we're looking at, let me erase. Now, if you already have an equation of a circle, you know certainly you're going to see a question on this tomorrow in your exam, guaranteed. Section 2, question 1, you're going to see this. So we have the equation of a circle is written in that form. Now, that is the general or expanded form, alright? And what we want to do is to determine the coordinates of the center of the circle. So we have this equation of a circle which is stated as x squared plus y squared minus 8x minus 18y plus 93 is equal to 0. So that's the equation of your circle, alright? Now, when it comes to a circle, the equation of a circle, you will always have a center and you will have a radius. Let me denote the center by h and k. Now, for the equation of the circle in the expanded form, that form of general form, now if the center is considered to be, if you're considering the center to be positive h and positive k, then you can write the equation. It's important to know the general formula for the equation of the circle, right, in the expanded form. That is x squared plus y squared minus 2hx minus 2ky plus c is equal to 0, where c, this constant, is equal to h squared plus k squared minus r squared. Alright? Now you'll see in the formula sheet, sometimes you see the expanded form as x squared plus y squared plus 2hx plus 2ky plus c equal to 0. Now that is if you decide to, it all depends on how you decide to consider the center. If you consider the center to be negative h, negative k, then you will write the equation of the circle as x squared plus y squared plus 2hx plus 2ky plus c is equal to 0. Where again c is equal to h squared plus k squared minus r squared. Okay? So you must include that part of the equation. What is c? So we have the equation of the circle in that form, the expanded form. So I like to normally use when h and k are positive, using the center where h and k are positive. And if that's the case, I'm using this representation for the expansion of the expansion form or general form of the equation of the circle. So this is what I'm going to do to find, because they ask me to determine the coordinates of the center, h and k, right? So this is what I'm going to do. See, now I'm considering the center to be positive h, positive k. This is the formula I'm using for my general form or expansion form. So this is what I'm going to do. X squared plus y squared minus 2hx minus 2ky plus c is equal to 0. And this is what I'm going to do to find h and k. I'm simply going to equate coefficients of x and y. So I'm equating coefficients of x and y. What are the coefficients of x? So I'm going to put those two equal together. Negative 2h is equal to negative h, negative 8. So I place those two equal to each other. And I'm equating my coefficients of y. I'm going to put what? Negative 18 equal to negative 2k. Alright? So I equate them, the coefficients. What exists in front of x for the expanded or general form, and I'm going to put equal to what is in front of x in the equation given in the question. And therefore, look at what's going to happen. I can solve for h now, which is negative a divided by negative 2. H is positive 4. I can solve for k now. This is what? Negative 18 divided by negative 2. K is what? Positive 9. So the coordinates of my center will be HK, which is 4, 9. That's the coordinates of my center. Alright? So using the general form, alright, to help you to determine what's the coordinates of the center of the circle. So let's get the other part of the question. Find the length of the radius. So we're going to find the length of the radius. So to find the length of the radius, this is what we're going to do. This is where this equation here, the addition to your formula, will come into play to help you to determine what's the length of the radius. So this is part 1. Part 2. So I'm using my formula C is equal to h squared plus k squared minus r squared to help me to determine what is my radius. So I know that C is this. C is, we'll have it here. C is what? 93. So I'm replacing C with 93. And I know h is equal to what? 4. I'm replacing h with 4 in bracket squared. I'm replacing k with 9 in bracket squared minus r squared. So I'm going to get 93 is equal to 16 plus 81 minus r squared. And therefore, 16 plus 81 will give me 97. So this is 93 is equal to 97. Subtract r squared. I'll take negative r squared and I bring it over on the right, on the left, sorry, as positive r squared. And I'll take positive 93 and I'll bring it over on the right as negative 93. So therefore I'm going to get r squared is equal to 97 subtract 93, which is 4. And r is the square root of 4. R is 2 units. Right? So that's the length of my radius of the circle. So using that additional formula, right, of the general or expanded form of the equation of the circle, yeah, to help you to determine what's the radius. Then they want us to find the equation of the normal to the circle at the point 2, 8. So the equation of the normal to the circle at the point 2, 8. Yeah? So remember, with these questions, they ask you to find the normal, this is the normal, which is the radius, or the tangent. The tangent is a line drawn to meet the circumference of the circle at your point of tangency, and it's always perpendicular to the normal. So if they ask you to find the tangent, note you have to first know what's the gradient of the tangent, which in turn will help you to find the equation of the tangent. But in this question, they ask us to determine what's the equation of the normal. So this is the normal here, which is the radius, right? So this is the normal. Let me draw the tangent so you can see what's the normal again. This is your normal. Normal is always perpendicular to the tangent. And they want us to find the equation of the normal to the circle at the point 2, 8. Let's assume that's the point 2, 8 on the circumference of the circle. Good? We got the coordinates of the center to be 4, 9. And they want us to find the equation of this normal. The equation of that normal, which is the radius. To find the equation of the normal. So you know how to find the equation of a line. We're going to use y equal to mx plus c. If we're using y equal to mx plus c, we must have information for the gradient, and of course we must also find the y-intercept c. So to find the equation, so part 3, to get your equation of normal, we're using the formula y is equal to mx plus c, right? So using that formula. Now m, of course, will be the gradient of your radius. You have 2 points, so let's get the gradient. M y2 minus y1 over x2 minus x1. So I'll call this x1, y1, I'll call that x2, y2. So let's substitute into our formula. M is equal to y2, which is what? 8. Subtract y1, which is 9. Over x2, which is 2. Subtract x1, which is 4. So we're going to get m is equal to 8 subtract 9 will be negative 1. 2 subtract 4 is negative 2. So the gradient is positive a half. So the gradient of your normal is a half. And having found the gradient of our normal, then we can find the equation of the normal by replacing y, m and x with numbers so we can find the value of c. Good? So, we know we're going to replace m with a half. And what are we going to replace x and y with? We just simply take a point on the line. Let me go with 2, 8. So I'm replacing y with 8 is equal to m with a half, x with 2 in brackets, plus c. So 8 is equal to a half by 2 is 1 plus c. And therefore I can subtract 1 from both sides. I'm going to get 8 subtract 1 is equal to c. 8 subtract 1 is 7 is equal to c. So the equation of the normal is y is equal to a half x plus 7. And that there will be the equation of the normal. Please make sure you know how to find the equation of a circle. You should know your formula for the equation of a circle in the expanded form and also the general form, right? The form which stem from Pythagoras theorem, which is like this. X minus h in brackets all squared plus y minus k in brackets all squared is equal to r squared. Please also make sure you know the equation of the circle in that form, alright? And of course, how we can find the center, the radius, the normal, and also the tangent. Okay? And sometimes I'll ask questions where you have a line cuts the curve at 2 points. And sometimes you'll have to solve that line and the equation of the curve, the equation of the line and the equation of the curve, of the circle, simultaneously to find the points of intersection. Sometimes you see that happening. Alright? All right, let's look at we can look at a circle measure. Alright? So look at a circle measure. And then we'll jump quickly to our vectors, alright? And then our trigs. Alright, so let's quickly do a circle. Alright, so looking at quickly a question on your circle measures. So suppose I have my circle, this is my center. That is A, B. I have my chord. This is the center of my circle. 0.5, that only C means radians, right? So the answer is in radians. The radius here is 10 cm. They want me to find the area of the shaded region. Alright? So the diagram below that drawn the scale shows a chord AB with subtends an angle at the center of the circle, 0.5 radians. And it has a radius of 10 centimeters. Given that the area of the triangle, and you should know how to find the area of a triangle, because when you have two known sides and the included angle, two known sides meet to form that angle, which is called an included angle. This is the formula you use for the area of the triangle. They have something like this. That's my angle. This is A, that's B. Two sides and an included angle. It's a half times A times B sine the angle theta. But because this is the radius, because it's the radius of the circle, we'll write it as a half times R by sine theta, or half R squared sine theta. So make sure you know that formula to find the area of a triangle. Yeah? Alright? So they want us to calculate the area of the shaded region. So to find the area of that shaded region, area of shaded region is equal to area of the sector, which is this region here. OA, B is like a slice of pizza, a slice of cake. Area of the sector, subtract area of triangle. How do you find the area of the sector? Make sure you know how to find the area of the sector when the angle is in radians. Area of the sector is a half R squared theta. Yeah? A half R squared theta. So please make sure you know how to find the area of the sector. Make sure also know how to find the length of arc too, right? S is equal to r theta. But in this case, we have to find the area of the shaded region, so you must know the area of the sector, and you know the area of the triangle is that formula there. This is what we have here. So let's get the area of the sector. The area of the sector is a half times r, which is 10 squared times theta, 0.5 radians. Subtract the area of the triangle, which is a half times 10 squared multiplied by sine 0.5 radians. So we're going to get what? This becomes 10 by 10 by 0.5 by 0.5, which is what? 25. Subtract, let's get the area of the triangle. This will be what? And remember, if you're using the angle in radians, you have to, the sine of that angle in radians, you have to ensure that your calculator is in radians. So change your calculator to radians. And convert it back to degrees when you finish, right? So we'll leave it in radians, and if you have another question where you have to use it in degrees, you'll make that mistake by working it in radians, alright? So always convert it back after. So this will be 0.5 by 10 by 10 by sine 0.5. 23.97. So the area of that shaded region is 25, subtract 23.97, which is 1.03 squared centimeters. So we find the area of the sector, we find the area of the triangle, and we subtract the two to give us the area of the shaded region. Alright? Yeah, so let's do a quick sector question. So I'm going to move on quickly now. I want to jump to a vector question, right? Jump to a vector. Ooh, that's very good. Jump to a vector, and then you jump to a trig. Then you will write it down on the left side of the board, right? And then you jump to a trig question. Alright, so after those a bit dark, so I'll write it on the board, right? The position vectors of 2 points A and B relative to an origin O are OA, 3i minus j, and OB, 5i minus 4j. They ask us to determine the unit vector AB. Good? So 1. The unit vector AB. So please in vectors, make sure you know how to find the unit vector, right? What's a unit vector? So the unit vector is simply a fraction of the given vector quantity. Yeah? So if this is a vector quantity AB, unit vector is just a fraction of it. That's the unit vector, it's just a fraction of it. So write the unit vector of AB. So put that in symbol up top to mean unit vector is 1 over the modulus of the vector AB times the vector AB. That's the unit vector. 1 all over the modulus of the vector AB times the vector AB. So, first we need to find vector AB. We don't have vector AB yet. But vector AB can easily obtain. Now, vector OA, when you have your vectors written in terms of the units I and J, you can convert that into a column vector. So you can write this as 3, -1, and OB you can write it as 5, -4. Good? And what you can do, you can use your law of vectors or the triangle law to find AB. So you can write this as vector AO plus vector OB will give you vector AB connected in that order. Alright? And if vector OA is 3, -1, then vector AO will be the change of signs. So +3 becomes -3. And -1 becomes +1. That's AO. Plus OB is 5, -4. What are we working out? What are we going to get? This will be -3 plus 5 and 1 plus -4. -3 plus 5 will be 2. A plus by a minus is a minus, and 1 minus 4 will give us -3. So AB will be equal to that. So having found AB, now let's get the unit vector of AB. So we also need to get the modulus of the vector AB. So let's get that one time. So the modulus of AB, it is formed by using the formula, the square root of x squared plus y squared. That's how you find the modulus. And you know in this case, this will be the square root of, x will be 2, so you're going to put 2 in brackets squared, plus y is -3, you put -3 in brackets squared. So this will be equal to the square root of 4 plus 9, which is the square root of 13. And you can leave it in terms of a surd, right? So the modulus of AB, that is the square root of 13. So this will be 1 all over the square root of 13 times the vector AB, which is 2, -3. And therefore, the unit vector of the vector AB is 1 over the square root of 13 times 2. You can multiply this by each. And 1 over the square root of 13 times -3. And that there is the unit vector of the vector AB. Make sure how to find the unit vector, right? And then they ask now, what is the acute angle AOB in degrees? Character 1 decimal place. Now you know we love to bring this in a vector question. To find the angle between your two vectors. So to find the angle between your two vectors, you know the formula you're going to use will be the dot product or scalar product, right? So we have so part 2, to find angle AOB is going to be what? Dot product. Using dot product, right? That will be OA dot OB is equal to the modulus of OA dot the modulus of OB cos theta. So please make sure you know the formula, right? To find the angle between your two vectors. OA, we know it is, I'll write it back in the form, we know OA, which was 3i minus j, is 3 negative 1, and OB, which is 5i minus 4j, is 5 negative 4. Right? Writing it as a column vector, right? So you know this will be what? 3 negative 1 dot 5 negative 4 is equal to the modulus, which is, you know, the square root of 3 squared plus negative 1 squared. That's the modulus of OA. Dot the modulus of OB is square root of 5 squared plus negative 4 squared cos theta. So what are we going to get? This is what? 3 times 5 plus negative 1 times negative 4 is equal to, this is the square root of 3 squared is 9 plus 1 squared is 1, 9 plus 1 is 10 dot, this is 25 plus 16, that'll give us what? 25 plus 16, 41, right? Cos theta. 5 by 3 is 15. Negative 1 by negative 4 is 4. And what we can do, you have two surds that we can multiply. The square root of 10 by the square root of 41 will give me the square root of 410 cos theta. 15 plus 4 is 19 is equal to the square root of 410 cos theta. And therefore, to get cos theta by itself, I need to remove the square root of 410, so I divide 19 by the square root of 410 is equal to cos theta. And therefore, to get theta by itself, I'm going to remove cos, which we know comes across as cos inverse. So it's cos inverse of 19 over the square root of 410 is equal to theta. And let's find cos inverse of that. So this will be shift cos, open brackets, 19 divided by the square root of 410, close brackets. Oh, I see. See, that's why it's important to change the calculator back to degrees. I left mine radians. Shift. Right, so that will be cos inverse 19 divided by square root of 410. Right, so you're supposed to have gotten as the angle 20.2 degrees. Alright, so making sure we can find the angle between two vectors, alright? Alright, let's look at quickly solving a trig equation. And look at look at this 2018 here. Alright? So let's make sure we know how to solve trig equations like as such. And then we have proven identity, right? Or even one like this with the compound angles. Alright? So let's look at one or two trig questions. Wow, it's after 12. So let's see what we can do, but I have to close off shortly. Yeah. Okay, so let's see what we can do now. I really wanted to do some differentiation, integration, but time wouldn't permit. Okay, let's see. Let's attempt solving a trig equation. So we want to solve the equation we have here, sine squared theta plus 3 cos 2 theta is equal to 2. Alright, we want to solve that trig equation for 0 is less than or equal to theta, which is less than or equal to pi. Right? Now, normally with trig equations, when you solve a trig equation, the answer must lie within a given range. It will give you that range. In this case, it's between 0 and pi. And because it's between 0 and pi, it means that your angles must be represented in radians. And keep in mind, because it's between 0 and pi, note pi is the same as 3.14. So really you want your range of values or your angles that satisfies that equation there to lie between the one of those angles between 0 and 3.14. That's the same as your pi, right? 3.14 is your pi. So at least you know what is pi, what value of pi they're looking at, which is 3.14. So how are we going to solve this trig equation to get all the values that satisfy the equation within the range? So this is a trig equation with two trig functions, in sine and cos. You don't want to solve a trig equation with two trig functions. So, what you want to do? I am seeing here a multiple angle or double angle, which is cos 2 theta. And keep in mind, you see, because this certainly you're going to see a lot, and you may see it in your exam tomorrow. A double angle. So make sure you know the double angle for sine 2 theta, cos 2 theta, tan 2 theta. Make sure you know those three important double angles, right? And the formula linked to them. Cos 2 theta has three representations. It's cos squared theta minus sine squared theta, that's 1. Cos 2 theta is the same as 1 minus 2 sine squared theta, that's 2. Cos 2 theta is 2 cos squared theta, subtract 1. That's what cos 2 theta is equal to, right? 3 of them. So for us to solve this trig equation, I want my trigger, my terms, to have one trig function. So I'm going to convert all into sine. So I'll leave my sine squared theta as is, plus I am going to convert cos 2 theta, and of the three I'm going to use this one in the middle here, because this one involves what? Sine, right? So I have 1 minus 2 sine squared theta. So I'm going to replace, this is 3, and I'm going to replace cos 2 theta with 1 minus 2 sine squared theta is equal to 2. Alright? What I'm going to do now is remove my bracket. This is what? Sine squared theta plus 3 minus 6 sine squared theta is equal to 2. Yeah? And what am I going to do now? I'm going to group like terms. So this is what? sine squared theta minus 6 sine squared theta plus 3 and positive 2 comes across as negative 2 is equal to 0. Yeah? And I'm going to get here now 1 sine squared theta minus 6 sine squared theta is negative 5 sine squared theta. 3 plus 2 is plus 1 is equal to 0. So I'm going to take my plus 1 and bring it over to the right. So this becomes negative 5 sine squared theta is equal to negative 1. And therefore to get sine squared theta by itself, I have to remove the negative 5 in front of your sine squared theta, right? So I'm going to divide both sides by negative 5. So sine squared theta is equal to negative 1 over negative 5. Sine squared theta is 1/5. Alright? But remember, we have to get sine theta by itself. So that power of 2 has to be removed. So you remove that power of 2 by finding the square root of 1/5. But you have to consider both positive and negative results. We have always been trained when you find the square root to only focus on the positive result, but you have to consider also the negative. So you're going to put a plus or minus sign in front of that square root symbol. Alright? So this will be sine theta is plus or minus the square root of 1/5 is what? Alright? The square root of 1/5 is 0.447. Yeah, let me just double check that. Square root of brackets 1 divided by 5 close brackets back. Yes, so that's the square root of 1/5. So to get theta by itself, I need to remove sine, which will come across as theta is equal to, let me erase this information here. Theta is equal to sine inverse. Now remember, we have two values of theta, positive and negative 0.477. So you have to consider both. So I'm saying sine inverse, let's start with the positive first. Positive 0.447. So I'm considering the positive first. So when you find the square root of 1/5, plus or minus the square root of 1/5, you're going to have a positive and negative result. And when you find sine inverse, you're finding sine inverse of both positive and negative results. Alright? So let's get all the values of theta that lies within the range for positive 0.477. Right? Sine inverse of that. So we're going to get theta is equal to, remember the angle is must be in radians. So this is where you're going to change your calculator to radians, right? So change the radians. So I'm going to find second function sine 0.477 will give me 0.49. And this is a 1 decimal place, right? So I'll approximate to 1 decimal place, that's 0.5. Radians, right? Little c at the top means radians. But we have to remember, when you're solving a trig equation, you're solving for both principal and secondary values. You're not just solving for the principal 0.5 radians and that's it. You have to get your secondary values. So to do so, you're going to use your quadrant analysis. All school teachers care. Good? And because you're dealing with sine and you're dealing with a positive principal value, sine is positive in A and S. You can ignore A and focus on S, which is 180 degrees subtract theta, but you have it in radians, and 180 is the same as pi subtract theta. And pi is the same as 3.14 subtract theta. So your secondary values, because it is in radians, is going to be 3.14 subtract 0.5. So theta for sine inverse of positive 0.447 will be 0.5 radians, and this is 3.14 subtract 0.5 will be 2.64 radians. Yeah, so 2.64 radians. So theta is equal to 0.5 radians and 2.6 radians. Alright, so that is for sine inverse of 0.447. Yeah? But let's also find sine inverse of negative 0.447. So theta is equal to sine inverse of negative 0.447. You also have to consider the negative result. That is what? Shift sine, make sure the calculator is in radians, negative 0.447. Right, we have negative 0.5 radians. Alright, negative 0.5. So, for us to get our secondary value, we have to use our quadrant analysis. Now, sine is positive, we're dealing with a negative principle now. Sine is positive in A and S, but it is negative in T and C. So those two quadrants are the quadrants we're going to use to help us to determine our secondary values. So in the third quadrant, which is tan, this is 180 degrees plus theta, which is the same as pi plus theta, which is 3.14 plus theta. And we want it in radians, so we're using 3.14 plus 0.5, and not plus negative 0.5. Negative sign is only there to indicate where sign is negative, which is in T and C. So you're not writing 3.14 plus negative 0.5, right? So you ignore the negative sign, and it's going to be 3.14 plus 0.5. Alright? And sine is also negative in the fourth quadrant. So which is 360 degrees minus theta, or 2 pi minus theta, or 2 times 3.14, which is 6.28 minus theta, which will become, if it's 6.28 minus theta, of course theta we're using as 0.5, not negative 0.5. So it's 6.28 subtract 0.5. Yeah? Not 6.28 subtract negative 0.5. But the negative sign is only there to indicate where sign is negative, which is in T and C. So you're going to get negative 0.5. It's going to be 3.14 at 0.5. It's going to be 6.28 subtract 0.5. Alright? So all our values of theta, and all those are in radians. So all our values of theta that lies within the range 0 and pi, or between 0 and 3.14 are 0. That lies between 0, and 3.14 are 0.5, 2.6, and that's it. Negative 0.5 doesn't lie within the range. 3.64 doesn't lie within the range. 5.78 doesn't lie within the range. So the only values of theta we're going to use are 0.5 and 2.6 radians. Those are the only two. Alright? So our trig equations. Alright? So the last thing I'm going to do is a proven identity. So I'll do this proven identity. Alright, let's prove the identity. Alright, so let's prove the identity. So they want us to prove the identity. So prove the identity. One minus cos squared theta over 1 plus sine theta is equal to sine theta. Right? 1 minus cos squared theta over 1 plus sine theta is equal to sine theta. So we have to prove the identity. You know when they ask to prove the identity, you want to prove one side is equal to the other. So to prove the identity, you begin by stating proof. Consider the left-hand side, which is 1 subtract cos squared theta over 1 plus sine theta. Yeah? And what I have to do is to simplify that. So to simplify that, I'm going to put 1 over 1. And when I'm adding or subtracting fractions, the first thing I'm going to do is to find the LCM. So my LCM here will be 1 plus sine theta. Right? So this entire thing is the LCM, 1 plus sine theta. So I'm dividing 1 into 1 plus sine theta is 1 plus sine theta. 1 plus sine theta by 1 is 1 plus sine theta. Bring down my subtraction sign. 1 plus sine theta into 1 plus sine theta is 1. 1 by cos squared theta is cos squared theta. Good? So now how am I going to simplify that to get what I have on the right hand side, which is sine theta? Never lose sight of what you want to achieve, alright? So my right hand side is strictly sine. I have no cos on the right hand side. So that cos squared theta, let me convert it into sine. So for my trig identities and relationships, I know cos squared theta is 1 minus sine squared theta. Very important identity or relationship. So I am going to replace my cos squared theta with 1 minus sine squared theta. So this will be 1 plus sine theta subtract cos squared theta is 1 minus sine squared theta. And you're not just going to write 1 minus sine squared theta. Remember, you have two terms. And this negative sign, of course, will be placed in front of those two terms. You have to make sure you place those two terms in brackets. That expression you have to put in brackets, alright? If you didn't put it in brackets, well, then we'll throw things off, right? So you put it in brackets all over 1 plus sine theta. Let me remove my brackets now in my numerator. I'm going to get here 1 plus sine theta A minus by a plus is a minus, or a minus by a negative 1 is negative 1. A minus by a minus is a plus. Excuse me. Sine squared theta. All over 1 plus sine theta. So what's going to happen here? My two ones, 1 subtract 1 will be 0. And I'm left with sine theta plus sine squared theta all over 1 plus sine theta. Now at that point, what students like to do, they like to cancel this with this and divide this into that. No, we can't do that. Once there's an addition or subtraction sign separating terms in your numerator or denominator, you cannot divide one into the next just like that. Okay? So the only way we can simplify this to give us sine theta is to introduce factorization. So what I'm going to do is to factorize my numerator. So in my numerator I have sine theta plus sine squared theta, and of course I can factorize my numerator. When I factorize, if I look in my numerator, sine theta is common, take it out as a factor. And I'm going to divide sine theta into each term in my numerator. So sine theta into sine theta is 1. And sine theta into plus sine squared theta gives me plus sine theta. Over 1 plus sine theta. Alright? So find the LCM. Once you have fractions, find the LCM. First thing, without a doubt, find the LCM one time. And then you see, of course, when you have to find sine, convert cos squared into 1 minus sine squared theta. You have to know your relationships, know your identities. You simplify it, you got to this point, and you have to introduce factorization to simplify to get sine theta. And look at what's going to happen here now. 1 plus sine theta into 1 plus sine theta is 1, and you're left with what? Sine theta. And we can state at the end, hence, your left-hand side is equal to your right-hand side. And what you do, you always put out like a box at the end, you can write QED. Right? Which indicates you have demonstrated your proof. Alright? That is proving your identity there. Alright, so after end now, right? After end the live now. But what I want to do is just to wish each and everyone all the best in your exam tomorrow. Please ensure that you answer questions well in the section 3. Sorry, I don't have the time to do any section 3, which is the differentiation integration. I hope you know your differentiation and integration well. That should be your trump card, so make sure you answer those questions well. Likewise, try to maximize on the section 4, which is your stats and probability. Okay? So the stats and probability normally comes very straightforward, so please ensure that you can answer those questions comfortably. So you want to gain most of your marks in section 3 and 4. Where students often lose most of their marks will be sections 1 and 2. Hence the reason I focus on sections 1 and 2. Okay, so please ensure your remainder factor theorem, your logs, your indices, surds, that is understood, well understood from your quadratic equations, everything under the umbrella of quadratics, from solving the quadratic equation by means of the use of completion of squares. Make sure you can complete the square and you can solve the quadratic equation using completion of squares. Quadratic inequalities, make sure you can solve a quadratic inequation. Make sure you can solve simultaneously a linear and non-linear equation. Right? Make sure you can solve those two equations simultaneously. Make sure you know your roots involving alpha and beta types of roots. Make sure you can sketch quadratic functions also. Yeah, that is what you see in question 2 along with APs and GPs. So make sure you review your APs and GPs. And in the section 2 of the paper, make sure from the equation of a circle to sectors to your vectors to trigs, those are well understood. So you can perform well in sections 1, 2, and of course maximize on your marks in section 3 and 4, which will put you in a very good position to pass the exam along with a solid multiple choice. Okay? So going to that exam tomorrow, you should say a prayer, ask for guidance, divine guidance, and just with a calm, calm frame of mind, yeah, enter the exam with confidence and do an excellent paper. Alright? So that said, wishing everyone all the best tomorrow. Take care. See you when it comes to the multiple choice.